Welcome back! In this video we are going to finish implementing our context steering in Unity. So let's start by creating 3 new scripts. We are going to create a steering behavior. Okay. Next one will be obstacle avoidance behavior. Okay. And the last script that we need is seek behavior. Okay. So let's start maybe by opening this obstacle avoidance behavior. Great. Let me paste the code here. And at the top, we are going to make sure that the class that we use for the inheritance is not mono behavior, but our steering behavior class that we are going to make into an abstract class very soon. So at the top, we have some parameters: series field, private float radius, and agent collider size. Radius is the same radius that we use for the obstacle detection. It will be used for our weight calculation, how important it is for us to walk in this direction of the obstacle, or should we avoid it at all costs. And we should avoid it at all costs if the distance is less or equal to the size of the collider of our enemy, in case our enemy should collide with other objects. So in this case I have assigned 0.6 f, which is a bit bigger than the collider on my agent. Now we are going to have a gizmo for our obstacle avoidance behavior to show us the direction that our obstacle avoidance has detected as the directions towards the obstacles. So we are going to have a private bool show gizmo and a float array dangers result temp. Next we are going to have this method public override that returns an anonymous structure that does not have a name. We just assume that we are returning 2 values from this getString method, and it is very useful when we do not want to create a new class or a new struct. Instead, we just want to return 2 values from this method. We're going to return this float array of danger and float array of interest. Now we are going to call this getString method, and this will be the override with the override keyword. So this will be the abstract method that we are going to put inside our steering behavior class. So this getString method will take in the same float array danger and float array interest, as well as the AI data, because we need to have the access to our obstacles detected by our obstacle detector. Now this is because our behavior will take in those 2 arrays, we'll fill them in with the appropriate values depending on the conditions that we put in, and it will return them back to our AI script so that another behavior can take them in and fill them in with its own values. This is because it will allow us to select the correct direction to move for our enemy. Anyhow, we are going to see it later. For now, we are going to have a for each loop. We are going to loop for each collider in our AI data obstacles. When we know about each collider, we can calculate the direction to the obstacle, which is simply obstacle collider, and we are using the closest point method, which should give us the closest point on this collider towards our agent, which is the transform.position, and we are going to subtract from it the vector to transform.position to get the direction to this closest point on this obstacle. Next, we are going to have a float distance to the obstacle. This is just equal to the magnitude of this direction vector. So we are going to cache it, because next we are going to need it for the calculation. First of all, we are going to take it into calculate the weight that we want to use based on the distance to the obstacle. So weight equals distance to obstacle if this is less or equal to the agent collider size. So if this is less or equal to 0.6, this means that we are very close to the obstacle. We want to give the weight value 1. We do not want to move in this direction. Else, we're going to check the radius. We are going to assign to the weight radius minus the distance to the obstacle. And we are going to divide it by the radius to get the sort of a weight that we want to use for our obstacle detection. Now we have cached this distance to the obstacle because now we need to normalize our direction to the obstacle. Now I'm caching it again in another variable, direction to the obstacle normalized. Now next we have some right squiggly line because we need to have a direction.addDirections.count. So let's slide at the bottom of this class, and we need to create another class called public static class directions. This is just a static class that contains a static list of vector to 8 directions, since, as I have mentioned, we are going to use 8 directions in our AI, and we are going to simply define the 8 directions, so cardinal directions plus 4 diagonal directions. This is this list of vectors. I'm defining it as a static list so that I can easily reuse it without having to redefine this list. If you have this, let's go back to our code, and in our for loop, when we have selected one of those obstacles, we are going to loop for each int I less than directions.8 directions, so we are looping for each direction, and we are going to select float result equals vector2 dot dot. So we are going to calculate the dot product of 2 vectors, direction to the obstacle normalized, and the one of those 8 directions, which should give us the approximate result of how close this direction is to the direction that we want to move in, or in this case that we do not want to move in, so the direction to the obstacle. Now, if you are not sure how the dot product works, there is this interactive way of understanding this. I will link this page in the description. Basically, this one vector is this red one, and the second one is this bluish one. And we can see that the a.b is shown here. So if we are very close, we're going to have this almost reaching 1. If we are very far, it will start reaching 0. Of course, this depends on the direction. That's why we need to normalize our direction. If we get to 90 degrees, it will be 0, and then it will take the negative values. So this allows us to say that if the weight is 0, this means that this direction will not lead us near this point where this direction is pointing. But if we move anywhere here, we're going to get closer than we were if we move in this direction. So this is the main idea of using the dot product for this calculation. Okay, so we have our dot product result, and now we are going to multiply this by the weight that we have calculated earlier. So depending on the distance to our obstacle, we are going to modify this and save it as the float value to put in equals result times the weight. And now, the one condition that we need to take into account when using the context steering is that if the value to put in is greater than what we already have in our danger array, only then we want to assign for this direction this new weight value. Okay, so when we have moved through each obstacle and assigned our values to each direction, because maybe there are 2 obstacles and one is closer, we are going to override the danger values for the values of the closer collider. When we are all done, we are going to assign danger's result temp equals the danger, return danger and interest, and this is how we return both of those values of those float arrays. The rest of this is just drawing gizmos, so if we have dangerous results temp, we want to draw red color in this direction by using this directions.8 directions time the result, the weight that we want to use, so that we can see visually which directions represent the danger for us. Now, of course, you can extract this direction static class to a separate class. You can keep it here. It does not really matter. Okay, let's save this. Let's slide up and let's open this string behavior. Right click on this and select go to the definition, because we need to make this into abstract class, and we are going to again define here an abstract method. So our method is simply public abstract. We return the anonymous tuple, and we are going to call it get steering and get in the float array danger, float array interest, and AI data. Let's save this. Let's go back to Unity. Okay, now we should be able to test it at least to show us the directions that our avoidance behavior and the seek behavior has selected. For now, let's finish implementing our behaviors by selecting and opening the seek behavior. Okay, let me paste the code here, and of course we need to make sure that our seek behavior is inheriting from the steering behavior. Great. So now, again, at the top we have some parameters. First one is serious field private float target reached threshold. This target reached threshold is very important for us because in case our enemy has lost sight of the player, it wants to go to the last position that the player was seen at, and this will just tell us if we are close enough or not. I'll explain it a bit better later when we can actually test it. Show gizmo private bool flag and we have this bool reached last target equals true. This bool flag, it will be important for the logic where we want to select the next target to follow. Next, we are going to have a private vector to target position cached and a float array interest stamp. It will be for the gizmos to draw the correct gizmos for this behavior. Next, since we are inheriting from the steering behavior, we need to override this getSteering method. The definition will automatically be created for you if you right-click here, quick action, and implement unimplemented methods from the abstract class. So here we have a couple of those if statements to check different conditions. So basically, if we have reached last target, only then we want to select a new target. Else we want to just pursue the previously selected target. So this seek behavior also selects the target that we want to pursue. So if reach target last target is true, we are going to check if AI data.targets equals null or is the count is less than 0. We are going to set the current target to null, and we are going to return from this not doing anything special. Else, if the targets are not null, if we have some targets, but we have already reached the last target position, we want to set the reached last target to be false, and we want to select the current target. We're going to set it to be equal AI data.targets. We will use link library order by, so right click here, quick action, and using system.link, it will be added at the top, and now we can use this order by method. So we're going to order the targets by the distance from our position to the target. So basically, this logic will select the target that is closest to our enemy, and based on this condition, we are going to get the first target, and we are going to start pursuing it. Now, if you expect that the current target might be null, so something might go wrong, you may want to use first or default, which will return null in case there is no transform in our targets array. So we have now the current target, and reached last target boolean flag is false. So we have started following a new target. So next, we want to cache the last position only if we still see the target. So we are going to do again the calculation, because based on this reached last target, this code might not have run. We have this reached last target equals false. So if we can still see the player, so if current target is not null and AI data.targets is not null, and if AI data.targets contains the current target, so basically if we still see the player and the player is currently the target that we are pursuing. In that case, we want to cache the position of the target, so of our player, so that we want to save AI data.currentTarget.position. This is because if we do not see the player, we want to move to the last seen position instead of trying to reach the player, because if the player is directly behind an obstacle, then our AI will start stopping and restarting movement in different directions, or can even just keep walking into the obstacle if we do not have obstacle avoidance. So basically, this prevents this behavior. We are going to reach the last seen position of our target based on this cached target position. So next we are going to have the if check. If distance, so vector to the distance transform position to the target position cached is less than the target reached threshold. So if we have reached this position, we are going to set the reached last target to be true, AI data.current target to be null, and we are going to return our arrays. Again, if we have reached the target, we do not need to modify those arrays because there is nothing to pursue. So we do not have any interest positions. Now, finally, we are reaching this context steering behavior result. So here, if we haven't yet reached the target, do the main logic of finding the interest directions. So vector to direction to the target equals target position cached minus vector to transform dot position. This is our direction. And in the for loop, we are going to loop for the interest length. So for each direction, basically, float result equals, again, we are going to use the vector to dot product to calculate which direction is closest based on the direction to the target normalized and the direction 8 directions. So for each of the 8 directions, we are going to get this result. And without any additional weights, we are going to check if result is greater than 0. It means that we are going to get closer to the target by following this direction, and we are going to use this result as the direct weight that we put in our interest array. Again, we are going to check if value to put is greater than interest on this position I in this direction, only then we want to update this weight. And at the end, we are going to assign this interest stamp to be the interest. This is for the sake of drawing the gizmos. And we are going to again return those two arrays. And later we have this onDrawGizmos method. First, we are going to draw the gizmo when we are going. So where is the last position where we have seen the player? It might be the player position or it might be somewhere else. And if we are playing and the interest stamp is not null, we are going to simply draw the green color, the direction, so the draw ray in this direction where we want to go. So based on our result of the interest stamp, we are going to draw which directions should we try to pursue. Okay, great. Let's save this and let's go back to Unity. Okay. Now, before we create our behaviors, let's go back to our obstacle detector, because there is one issue. Since our enemy, the collider of the enemy is here, but the obstacle detector is above. So what we may want to do is move it in the center of our collider, so it detects the obstacles in regard of the center of the collider of the enemy instead of in the center of the sprite, in the pivot point of the sprite, because this will ensure that we avoid getting close to the center of our collider. So the 0.6 distance that we have set here will apply to the center of the collider rather than somewhere here. In turn, target detector will shoot a ray in the direction, so it is best to leave it as the level of the eyes. So we are going to shoot the raycast from this point. Okay, so let's create our behaviors. So let's create in the enemy, right click, create a new game object. Let's call it steering behaviors. Okay, and let's make sure that the transform is at 0, 0, 0. I'm going to create two more game objects. One will be obstacle avoidance and Control D, and second one will be target or seek behavior. I'm going to drag on both of those the respective scripts, so the seek behavior, and I'm going to drag the obstacle avoidance behavior. Okay, great. So now we should be able to select those, and there are no visible gizmos because we need to play our game. And to make sure that we can run those, let's reopen our enemy AI script. Okay, I'm going to create an array or list of those steering behaviors at the top of my enemy AI. Okay, and also we will need to have the code that runs those. So let me slide down to the perform detection. And in the perform detection, we are going to create two float arrays. And below those two lines, we are going to create for each loop steering behavior in steering behaviors. We are going to return this danger and interest. This is how we are going to get those values, and save those in the danger and interest float arrays. And we are going to call behavior get steering, and we are going to pass the same danger and interest arrays as well as our AI data. Now this should run our behaviors, giving us an opportunity to see what is the output of those using the gizmos, the gizmo code that we have added to all of those scripts. So let's save this. Let's go back to Unity. Okay, great. So for now, let me disable the ground tile map so that we can see a bit better what is going on here. We're going to select our enemy, and in the enemy AI script, let's make sure that we assign our obstacle avoidance to the steering behavior and the seek behavior, so that both of those are added to our steering behaviors list in our enemy AI. Now we should be able to press play. Okay. Make sure that you go to the gizmo toggle and disable the, let's slide the 3D icons to the min. And now you should see that those are very small. And now if you go to your detectors, make sure that you disable the show gizmos for the detectors. Now we are going to select our obstacle avoidance, for example. And now make sure that this is gizmo, show gizmo is checked, and seek behavior, let's for example disable it. Let's select our enemy, and let's use the move tool to move the enemy close to our obstacle. As you can see, there should be a red line pointing towards this obstacle. If we try moving it, it will start updating those. Let's maybe slide to this bottom one obstacle. Okay, and you should see now that those red lines are pointing in this direction. If we move our enemy, those should become longer as we slide it, so to point out that the obstacle now is above our enemy. So now we see that those lines are pointing in this diagonal direction as well as up and to the left. Okay, let's now disable the obstacle avoidance gizmos and let's select the seek behavior gizmos. If we select our enemy and slide the enemy, we can see that if we slide the enemy around our player, we can see that those interest directions are changing depending on where we are placed in accordance to our player. So this is how our steering behaviors will output the direction that we want to use for our movement. Now, there is one issue that I have discovered in my setup, that if I move my player, this red icon and this gray circle should represent the position of our player, and it is not changing when I'm moving my player. And this is because my setup is that I have this hit collider as a child of my player, but the enemy obstacle and target detector is only detecting one of those colliders, and in the logic they are not equal to the collider in the array, and there is the issue. So what we can do to fix this, we can select the player, select hit collider, and let's copy this. So let's select those 3 dots and copy component. Let's delete this hit collider, and I'm going to place it on my player game object. So I'm going to click those 3 dots and add any of those components, and I'm going to paste component as new, and here I have the capsule collider that is trigger for the easier detection using the array casts. And now I need to open the seek behavior. Okay, and here the issue was in this last in this line just after we have set the target. We were caching the target position, and here we have this logic and a data the targets contains this current target. Since this current target transform reference will be the same transform as the small collider and as the big collider, this target should contain now the current target as well. So this condition should be satisfied, and this position should be cached correctly. Okay, and now if I move my player, you can see that this is being updated. And now if I leave the area of the detection, now the enemy doesn't know where the player is because the player is outside of the near area to the enemy, and now this is the last seen position where the enemy will try breaching before it will give up the pursuit unless it starts seeing again the player. Because if we now drag the enemy closer, you will see that this starts updating again because the player again is in the near range of the target detector of the enemy. Okay, so this is it for the detectors and the steering behaviors. I hope that you have enjoyed this tutorial so far. If you did, leave a like, leave a comment, subscribe to the channel, or click the thanks button. It would really help me a lot. In the next video, we are going to tie those detectors and the behaviors together to actually output the concrete direction where the enemy will start moving, and we are going to code the logic to make the enemy move. Okay, see you in the next video.